Should I start this talk? Right?
Yeah,
Yes.
Ken and Ravi will do the formalities, and I'll briefly introduce you, and then we'll start.
Okay, sure.
Okay, welcome everyone to the Ontology Summit 2024. Today is the 17th of April, 2024. And I'm pleased, very excited by the speaker today, who is AmitSheth, who will be introduced by Ravi Sharma and Ram Suram. So Ravi, can you take over?
Yes. It is a great pleasure to welcome Professor Amit Sheth, whose bio is very extensive and will be partly covered by my colleague, Dr. Ram Sriram. We are very delighted to have you again, sir, and it is a great pleasure to hear your vision and also the fact that you started this institute at South Carolina. Thank you. Ram, kindly go ahead
Yeah.
and introduce our
Yeah,
speaker.
thank you, Ravi. Again, it's my pleasure to have Amit Seth here. I've known Amit for several decades, from basically initially from his work on integrating heterogeneous databases, and then through the semantic web, and now he's been working on the NeuroSymbolic AI. And one of the domains that we kind of intersect is the healthcare domain. And I've been following Amit Seth's pioneering work in all these areas over the years. He's truly a fascinating guy in terms of research. And one thing I was fascinated by is that when I visited him and I got to the Wright State University several years ago, I was kind of wondering, I worked in MIT, and then we have some of the best students out there. And then, the students plan to play a big role in these things. And I went to Wright State University. I'm amazed how Amit kind of transformed the students who came from all kinds of small colleges from all over the world. And he kind of turned out some extraordinary work out of them. And that's kind of amazing characteristics of a great leader. So, Amit, I think, I really appreciate how you have transformed those folks. And then doing like state of the art work, as you can see that he has an H index of 117, which is I think can be rated as one of the top scientists in the world in terms of the H index itself. Okay. So, and he's also been pioneering neurosymbolic computing for quite some time. When everyone was gung-ho on neural networks, Amit kind of realized that it's just not the neural networks, but you got to combine them with knowledge graphs and those kinds of things to make the real thing happen. And just before you kind of everyone joined us, we had a few minutes and we asked Amit was talking about his experiences with the Prime Minister of India. So you can see even the world's one of the largest democracies in the world, I guess probably the largest democracy. Its leader invited Amit to speak to his chief secretaries and chief ministers on how on the role of AI for future in India. So again, without much ado, I'll give it over to Amit because I can be talking forever on him. So given the time, Amit, go ahead.
Thank you very much for this invitation. This summit is, gives probably the best, it's some of the best audience that one could hope for. And this was a very kind introduction, Ram and Ravi. And I'm particularly happy Ram noted the activity that I have loved the most of transforming. I may have start with the students at lower end than some of the top universities, but when the outcome comes, I'm very delighted that 45 plus PhDs and postdocs are doing exceptionally well in academia and tier one universities and entrepreneurship. One of them has unicorn and industry research. So I'll talk about the issue of neurosymbolic AI, some of the important reasons why I think we all understood the value and importance of the scale that has empowered the neural network-based solutions. And it solves some problems very well. It gets though buried in that the problems that it solves are of particular kind, classification, search, many others. They are undoubtedly important, but there are many other kind of problems and applications that the real world has. deliberative, one that lasts for a long period of time, one where the expert knowledge is critical. You just can't learn from the data and let the system go. So there are broad class of applications for which we still don't even think about using generative AI. And if AI has to, play a more vital role, I think we need to further progress and go well beyond generative AI as our solution. So that's generally the area in which I'm going to talk about. Um, um, the AI Institute now, I started, I was asked to create a university institute, AI Institute at University of South Carolina in 2019. So, and we started with 6 of my students moving from the previous center. It's now nearly 50 people. So that's been, in 4 years, it reached around that stage, 45 to 50 people. That's a pretty good size organization. And what has been distinct about our work is that, yes, we do work in a bunch of AI areas you see in the inner ellipse, but most of our work is also translational. So while working on foundational AI, we apply to a variety of domains and application. In particular, it's not just taking some benchmark in these domains and all that, working with real people, and working in each of those disciplines, getting the real world data from those disciplines, using them for validation and verification and other things of that nature. So that characteristics of work has, I think, prepared our students very well for the real world. And also it has, in a way, I have done 4 startups, mainly by licensing our own research based outcomes in the university to start the company. So that it has also helped this kind of knowledge and technology transfer. The work that I'm going to discuss today has particularly been applied to healthcare area, to pharma, to autonomous systems, smart manufacturing, and education, among others. I think it's not important to see that. All of you probably know about these, very broad framework that DARPA used, saying that there is a symbolic AI of the last century, first 2 decades of statistical AI, and then where we are now getting into this third phase. And I characterize that as a NeuroSymbolic AI, where you can explain, you can do contextual adaptation. These are the sort of terms that DARPA has used and defined. Now we started with formal or symbolic knowledge, and this community is knowledgeable. Many of you are more knowledgeable than I am. And with this, we could do certain reasoning very well: deductive reasoning, inductive reasoning, abductive reasoning. And the scale was a challenge. The amount of effort it went was a challenge, but it had these benefits, and these are really important. But in the systems, without if you don't take care, you could lead to nonsensical outcomes, like this Daffy Duck is a duck, but and ducks are real, so on and so forth. So connecting that and grounding this kind of stuff is very important. Grounding can be done here, but efficiently doing the reasoning wasn't there. We develop, sort of the expert system kind of thing. All of you are very well aware of those things, and it has several advantages and disadvantages. And then we moved into, around the turn of the century, into the semantic web and knowledge graphs. And, supposedly people are worried that a lot of effort goes into building these knowledge graphs. And that's why some people shied away from this particular approach, although I think that's not quite right. In year 1999, I started a company called Tali, which became Semantics, and I was awarded, we were awarded patent filed in 2000, awarded in 2001, where we basically talked about a semantic search, which where we built a very large WorldModel or knowledge graph, and connected that with both machine learning and knowledge-based approaches to create semantic search. it was remarkably the same as what Google did again in 2012-13 when they came up with semantic search. So you can, if you look at pattern, you will see all those knowledge graph. You will see info box kind of equivalent of rich media frame that we had presented and so on and so forth. Now, following that, we of course have start to see this informal. In 2005, I wrote a paper called "Semantics for the Semantic Web: The Implicit, the Formal, and the Powerful." And so, either informal or implicit, aspects here of dealing with came from via use of statistical techniques and then neural networks. So. It has done very well for many issues, but some people have been trying to claim that it can also do reasoning well. There I beg to somewhat differ in that their reasoning verification strategy is purely empirical and unprincipled. They set up a benchmark and show some incremental progress. I don't think that's the way to really get reasoning. This is basically a black box, and to provide reasoning in a principled manner is not something that they do. So yeah, you can kind of have some incremental improvement through prompt engineering, chain of thought, and other things. But it's interesting that requires a lot of human expertise and involvement, just like human expertise may be involved in writing the rules and creating knowledge graph. Although knowledge graph now we have developed a fairly powerful platform for creating knowledge graph from unstructured, semi-structured, and structured content sources of content. So even there, engineering-wise improvements are coming rapidly. So that's what leads to this NeuroSymbolic AI. And later on, the two broad variety of NeuroSymbolic AI, or maybe three. There's one something called physics-inspired version. There is a logic-inspired, based approach, and there is a knowledge-based approach. And here, some time ago, I had written also a vision piece on semantic, cognitive, and perceptual computing. And there I had argued that through semantics you can ground the concepts in the real world, concepts and data and such. You need a cognitive component, which is also some people talk that in the form of system 2, and you need perceptual component. People also call that system 1 kind of activities. And I think the NeuroSymbolic AI, as we look at it, is to bring these two things together: perception, cognition-centric components, data-centric, knowledge-centric component, system 2, system 1 components, and such. So, and the more important thing here is, and particularly important thing is that we want better control over safety and user level explainability and some other things I'll talk about, so that it can engender trust in the system, which is what is largely missing from the generative AI solutions. So this is there's a small article we wrote, NeuroSymbolic AI, why, what, and how. And this is a taxonomy out of that. You'll see on the left hand side you have essentially a symbolic structured knowledge compression for integration with neural patterns, and then another thing is called integrated neural pattern based reasoning. And these lead to a couple of solutions that or architectures and approaches that I will talk about in the next 2-3 slides. And there you can see on the top one, which is 1A, there is a compressed graph representation based method, while 1B is compressed logic represent based method. And so you had this proposal logic based thing and first logic based logic neural networks. The article gives a citation to each of these approaches, and you'll see that I try to characterize algorithm level features and application level features, which help you kind of get some insight as to how they compare with each other, low, medium, and high, just at a broad level. More important is the number two. And number two, you have a neural pattern lifting for integration with symbolic structure knowledge, also called and symbolic structure knowledge based reasoning. And there, in 2A is, somewhat decoupled integration, and 2B is intertwined or deeper integration. And right now, my team is primarily focused on 2B. There is work like probabilistic programs. Tenenbaum has worked in that area. To my knowledge, that has been with toy data size problems also. But conceptually powerful, but I haven't seen that for large on a large scale. Very quickly, the first simplest method is to take use embeddings, and incorporate knowledge graph, content of knowledge graph through embeddings. And because there is a lossy compression of the graph information or world model, there is some benefit, but the benefit are very limited. There are a couple of examples here. This is something called K-adapter. You can see here there is a knowledge source on the left-hand side, and that knowledge graph is incorporated into the transformer layer with a basic vector. And you see there with the pink pipeline, the vectors are basically added up, and it provides some benefit to give you just a very high-level insight. You ask a question to this saying the native language of Manmuti is, and the correct answer is Malayalam, but it does better than, but the K adapter, which does better than Roberta, does give Malayalam, but then it also gives Mandarin in one of the answers. And there is really no relationship between this question or query and Mandarin. So there are these problems with this kind of system. The next one is one that we developed, initially called KI-BERT, knowledge infused BERT, and later on, another one where we took the knowledge graph and created the mask, and then multiplied with the attention matrix, and that led to something better. It's also what Kala did, and you can see, you can find synonyms: World War I, First World War, so on and so forth, and related concepts, and that worked better. This was, I think, a slide from also KI-BERT. Then there is a decoupled way of doing this. I'll just take this example where people combine GPT with Wolfram, and saw that there is a mathematical problem in this question, and so use Wolfram to solve that part of problem and combine. So that's another class of system. And then there is now intertwined integration between neural and symbolic methods, where one of the ways we work is to elicit graph from the neural networks and compare and combine with the knowledge graph to create a controlized subgraph for much more handling of much more control over the application, whether you're doing question answering or whatever else you are doing. So here is an interesting example. This is an example where you're trying to understand, let's say, Reddit post, and you're trying to understand, what kind of suicidal thought there is. In the process here, not only use neural network to map a SNOMED concept like intrusive thought to whatever may be the phrases and entities that may be described in the text, that something neural networks do fairly well. But you also utilize explicitly, the process, so decision making here would typically require you to follow this some sort of guideline or process that you're seeing in bottom left. And that is a reasoning process or thinking process that you need to go through. And that is coming from, and in your in this integration, you are ensuring that you are deliberately going through this process and then deciding whether this is suicidal ideation or suicidal attempt or whatever other thing it is. There is also access to a definition, like you see this DSM concept, and it has, people have obsessive, intrusive thought, ideas or sensation that blah, blah, blah. So there are concrete concepts, and that you are able to tell that this is OCD because I find explicitly mention of all these three, or whatever the thing, or is or whatever the definition says. So I'm able to explain that you are getting, what you're getting is not just the classification, but why, right? And this approach we call process knowledge infused learning did far, better in terms of your accuracy, but in addition, it of course is flexible, open-ended, explainable, consistent, safe. Those kind of capabilities is what you get using this strategy. Here a different kind of content where you don't have textual data, but you have question answering over some visual content or video. And in this particular case, using scene ontology, also joint work with Bosch, we you can see on the left hand side a graph that can be extracted, and you can so you have causal event graph, and with that you can then have the neural network is helping you with the question answering, but the deeper insight as to what actually is happening in the scene, and the physical interactions between these blocks and such, that you can do, and you can explain through the explanation graph you see on the right hand side. So promise of NeuroSymbolic AI, it's good at cognition system 2 capabilities aided by symbolic reasoning, knowledge model conformant, explainable, consistent, safe, and interpretable, and good at perception system 1 capabilities aided by neural net inferencing that gives the flexibility and really scale and many other things. So we have been, we have had applications in autonomous vehicles, smart manufacturing, health, co-pilots, and some others on this. Now, with these outcomes that NeuroSymbolic AI, knowledge-infused NeuroSymbolic AI support, what we want to do is to connect all these things. That's a good system capability, but you want to connect with the real world and supporting real world application. For that, we need to start thinking about alignment, where system behaviors are in accordance to end user explanations, grounding, where system is grounded in the domain and world knowledge, and instructability, where the ability to guide the system to incorporate additional contexts and constraints. For example, there will be health co-pilot, and while many things it can take care of in conversation with the patient, there are times where the expert need to take control, modify the process, provide additional context necessary, and change the behavior of the co-pilot. So those are adaptable and contextually adaptable systems that you need to do. Now, we've been looking at relatively comprehensive and complex applications. One of them happens to be this so-called multi-tier support system for assigning care services to students with problem behavior. This is a big problem. All school districts, I think nationwide, are required to provide some level of mental support to students. And in a couple of years ago, South Carolina had one counselor for 1,300 students, way more than the state required no more than one for 325 students. So you really need to bring in technology to scale and take the workload. And even when the with the high workload, these counselors can't really keep track of, they can't go back and look at much of the past data about the students, and there are, so they just work in vacuum because they have to work fast and support so many students. So there are a lot of challenges here. But basically, the way the system is set up is that you have students and school staff who create this so-called disciplinary review or staff meeting review text, and then they pass it on to this MTSS system that consists of an ecosystem of a school level team and district level team, and they have access to protocol, although most of the people cannot take care of consulting the protocol or adhering to protocol, because there's so much content, so many aspects of the protocol that people just can't remember. So very highly experienced person works well, but a new counselor who might not be trained much and may not have much experience, may end up doing taking actions that are not consistent with the protocols that you have. And in this case, the services are set up. There are a tier 1 called universal service, tier 2 called targeted service, and tier 3 called intensive service. So intensive service comes close to what happens if somebody with mental health problems sees a clinician. Indeed, that will involve a medical professional. The others don't. They require people with low level of expertise in mental health management. So now here, what you see is that in managing this thing, you see a lot of exchanges that go on. So you can see blue is school level team member, yellow is the district level team member, and gray is co-pilot, AI co-pilot that we are working on. And you can see that there are interactions that can be classified as deductive reasoning 1, deductive reasoning from protocol plus inductive reasoning from data 2, and retrieval augmented abductive reasoning number 3. So there is a bunch of communications that are going on, and that Copilot is supposed to help these people ensuring that these interactions happen efficiently, adhere to protocol, and so on and so forth. So with that workflow, here you see we support grounding. So you can support grounding in procedural knowledge. You can support grounding of concepts. In this, you support instructability, whereby it is possible for new knowledge to be, or to be considered and brought in, and the behavior of the agents can be changed or interactions can be changed, and that but the scale and control is difficult to achieve with all this complexity. What we are looking at here is to develop a targeted and customized knowledge, also compact and controllable network trained on curated data. Although I'm not discussing much in detail, there have been a number of approaches that are going on for different kind of model architectures like Mamba to create compact models. There is hardware acceleration kind of things going on, and also there are memory optimization things that are going on. So the idea is to create is not to use large language models. There are many problems with large language models, such as if you give customer data or patient data, that's not privacy. And so at least at this point, use of large language models is simply prohibited in some of the applications. We are working with a bank, and they simply wrote in our contract that we shall not use ChatGPT. So even though we have use of generative AI, this is prohibited in some regulated environment, privacy, environments which values privacy and security and other things. So you really have to create your what I call as compact and custom models. And so we are engaged in creating this very highly unique activity where these models are compact, so they can run anywhere, basically on mobile device even. And we are working on hosting this on phones and other things. But they are also custom. And custom has a very interesting aspect. I want to control the data it is trained on. I want to control the knowledge it is trained on or it uses, and I want to have, in let's say ChatGPT, you have um, the human verification and improvement, right? So RLHF, right? So but here I want to have a very well defined verification, test suite that will be processed by domain experts, not some mechanical turks that these large language models use, because interpretation of medical concept is not easy and challenging. So we are going to we're going to involve, and we have done some preliminary work there already, but they will be done highly verified, in addition to quality improvement. So this custom and compact model is a very unique approach that we are doing that will give you a lot more control over your environment, and of course better safety, explainability, other things that I've been talking about. And then basically these NeuroSymbolic systems are added to Planner, are working with, are enabling the Planner. So the planners are NeuroSymbolic Planner, and where you see interface and workflow logic, which does the scheduling and orchestrates interaction across different aspects, school copilot, finance copilot, and other things like that. But you can see that the systems are relatively complex. As the problems are complex, as many people are involved, as a sensitive subject like mental health is involved, and so on and so forth. An interesting concept that we have developed is called Alleviate. This is a series of health chatbot or copilots that we have developed. One of them is MH, mental health. And there is a demo which I won't walk you through. But basically, the conversations are happening on the left-hand side, you see there. And on the right-hand side, you are seeing everything that is understood by the system. So you have the knowledge graph. It tells you what are the concepts being discussed, how that concept relates to other ones. How does the system find that if you're doing fluoxetine, that you should, you would have a side effect like irregular heartbeat. If the irregular heartbeat concept shows up, you can suspect that there is a fluoxetine side effect. All those things you can observe, and this right-hand side allows you to really understand, system understands what's happening, and hence the auditing and explainability, through explainability and safety, can be done by domain experts. Let's see. So there are some details of all these, but I want to talk about just show you two parts. So on here, what you see is a conversation with a LLM based chatbot, and it did come up with a question: do you feel elated or self-destructive? Now, according to clinical experts that we work with, in this particular case, talking about self-destructive would be harmful to the patient. So we have the medical questionnaire, knowledge from medical questionnaire, enhanced form of medical questionnaire like enhanced form of PHQ-9, which capture such knowledge as to say you should not ask about self-destructive behavior. And so we create the questions that are medically valid and safe in the right sequence. So this is an aspect of safety. Again, I'm interested in the user level safety, application level safety. I'm not talking about the safety at the system level, which may give you probability that you followed this particular use for this particular data to come up with this thing. That's not what I'm talking about. That is not of much value to the applications. And here, it shows how explainability happens. So you can see in brown text, bisexuality, chaos in my relationship. These concepts are mapped to the knowledge graph concepts. Within the knowledge graph also, you can see that you have hierarchy. So feeling hopelessness would be part of the level of, would be subtype of level of mood, or intrusive thought is a, part of disturbance in thinking. So if you have in case concepts, if you have things stated in different context, in different ways, through the hierarchical reasoning or other forms, you are able to deal with all these things semantically, and you are able to provide explanation that is consistent with the understanding and guidance of the that particular domain. So OCD is defined as such. It can tell you, I consider this to be OCD, not only just classified, but because it meets this part of the definition of OCD. Now, there are a number of other use cases that we work on. Let me look at the time. Okay, so I have a few minutes more. So here is a use case in smart manufacturing. In this particular case, you have factory of future cell. So we actually have a deployed, sort of shop floor or factory in our, with my collaboration. I have collaboration with mechanical engineering, and they have all these things deployed, and they have sensors of variety of kind. And here our applications about a rare event or anomaly detection and prediction. So, you may have a lot of questions. You see on the bottom left, which sensor is producing an anomalous value, which equipment is manufacturing, what type of anomaly it is. All these are the kind of questions that you want to be able to answer. And, you need an analyzer and reasoner to be able to do that. So this slide kind of shows what happens today. There is a data processing step where you enrich, do data enrichment, and there is a prediction method for 2D anomaly prediction in assembly pipeline. And this definition of events and rare events. Now, today, what happens is that you have a model, and you can see that model says that number 11700, that data value is anomalous. That's why you see 1 is anomalous, and possibly say that the sensor corresponds to RO2 grip port, and that therefore that produce anomaly. However, by using a factory of future ontology and a process ontology, or assembly workflow ontology, which has temporal aspects to it, and we can now create what you see on the right hand side, a whole kind of a process that explains how robot 2, which has gripper, which has potentiometer, which has value for this gripper pot, and then by creating a loss function, you are able to explain, to identify exactly what happened and explain, identify and explain the event much better than the other systems do. The last point that I want to mention here is that humans are guided by and subjected to laws, regulations, policies. A bunch of concepts that have come up. Somebody has defined something called constitutional AI. We have had papers on AI and civilizing AI, and also this NeuroSymbolic value-inspired AI. So, values, social, cultural, individual-centric norms is something that we discuss in a paper, where personal level, community, or collective level, knowledge were discussed, or values were discussed, and then represented as in knowledge graphs. We talked about that thing there. And then, here now we are developing these value-based AI systems that, captures the complexity of all the things we discussed. On the right-hand side, though, you have societal values, you have the explainability. So variety, you have safety awareness, your personalization. So one thing I did not discuss is that I introduced the term, what is it called? Personalized health knowledge graph in one of the workshop papers long time ago, and then Google had a follow-on paper called personalized knowledge graph. But the point here is that as these systems like co-pilots or chatbots interact with the humans, you can those interactions, which may be in text or even visual forms, should be converted into structured form as a knowledge graph, so that you have which should have, of course, temporal component, so that you keep with personalization, personalized information. It can be still be under the control of the end user, so for the privacy and other reasons, but then it will interact with the broader system, and such that it will guide the patient or individual user in a way that preserves the privacy and other things. But basically, there must be a way to define these value aspects, and that incorporate that into the AI system. Again, with a neurosymbolic approach, with the symbolic part is well suited to capture those values that you need, and thereby you can develop neurosymbolic. Thereby you can develop a more a powerful system. I don't see a hope of doing that without this kind of approach. So here, this is just a broad architecture we are working towards. You can see the metacognition layer, which kind of identifies whether there's a cart on the. In most cases, you would not find cart on the road, but in case cart on the road, you have to react immediately, and you'll have perceptual part taking over, and you'll use neural network for that. While for other things, you'll take the cognitive aspects, playing the role, and both of them will be connected. And also, some of the more interesting things is that today the neural network architecture is very basic, but I think that there is work going on. I'm always inspired by work in neuroscience and cognitive science, and that there should be a richer representation of these neurons, and they would be supporting, our brains have a lot more diversity of the neurons and the synapses than current neural networks have. So I think we'll be making progress towards richer forms of neural networks, and then with the use of richer knowledge for all kind of things, we'll do better value support and explainability and other things like that. So with that, I saw quite a bit of, and this is 45, so 12:45. So I saw quite a bit of chat thing going on. I did not read any of them, but we can, I guess, we have plenty of time to discuss.
Thank you, Amit, for that excellent talk, and there's a lot of material that you covered. I'm sure people will be having questions. But I think, Ravi, you're going to moderate the question and answer session.
All right. I do not see any hands raised yet, but I have a lot of questions from the chat, and then Todd had some. So may I begin first?
Of course.
Amit, you have covered two big areas, two very, very big areas. One has to do with mental health and how you design systems that capture and influence the behavior of human mind. So that is one area I got to learn a lot today. The second, of course, briefly touched was on manufacturing area. But regarding the first one, there are several questions. One is of trust, another is of level of cognition. Third is, how do you capture events that trigger pathological behavior which needs to be attended urgently? So all these questions relate to the first case, and also that it is so hard and it's so culturally and language-based experience of mind that many times is connected to mental health. So how do you model such complex things? It's a general question, but I thought I asked.
Well, our approach is I work with Dr. Meera Narasimhan, and she's head of our uh, 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 neuropsychiatry, or that particular domain, and actually is a practicing clinician providing mental health services. And then I work with, and there are several others. We work with Dr. Jeremy Shrum, which is a psychiatrist and also does clinical psychiatry program. And then we work with our whole large center on school mental health, that and that's why you see the, for example, application both for the Alleviate MH and the MTSS are fairly different in the school of mental health itself. We want to cover both traditional clinical examples. For example, doctor says, here is how you should maintain your mental health from, and the doctor sees a patient once every 3 months or 6 months, and within all this time, every day patients condition changes. How do, through the interactions, and I did not discuss, but we also work on use of passive sensors, variety of sensors like stress measurement and many other things. So there is one use case we had in asthma where we had 29 different parameters and a lot of
Yeah.
different sensors involved. But so first of all, it's a very wide scope of mental health itself.
Yes.
The only way we can learn this is, first of all, I'm not going to become a mental health professional in my lifetime. So the way to work is to pick very specific use cases or applications, and define the objectives with these people that do it day in and day out, and do it carefully, because they are highly attuned to the restrictions and the safety that you have to have. So for example, creating the verification harness is a significant process to talk to them, create all kinds of questionnaire, identify all possible answers, checking, having them say this is allowable and this is not allowable, and why it is not allowable, what was objectionable about it. So you create this kind of stuff, and and then after even doing all that, you also have evaluations by clinicians, and then you take to the evaluation by the patients or the end users. The MTSS scenario that you saw is wisely and carefully avoids direct communication with the, it does not involve direct communication with the students. That remains as it is today. It only supports the mental health professionals, which, because working with the students would involve, school students would involve children or persons of younger age, IRB, and all kinds of challenging issues will show up. So we are working with the professionals there and supporting the professionals and making them more efficient.
Thank you. That is very big subject. I was only referring to the IT components like complex event processing, some events, trigger capturing, things of that sort that IT can work with. And obviously, our colleague John Sowa keeps emphasizing the value of cognition in all these deliberations. I'm sure if he's there, he will ask questions.
No,
Todd
and the
has his hand up.
cognition part is, the neural network, purely generative AI systems are very weak there. So this is where we have so many things human brain does, all the applications we involves both of them, and it involves both of them in a very interesting interlude manner. We don't fully understand that, but at least we need to start by having both of those capabilities. And and that's why in the last slide I had this metacognition. We are not perfected any particular way of doing that, But that's what we need to understand as to what kind of processing is necessary and how can we support based on our current understanding of these computational systems, ones on neural network based, ones on symbolic based, that isn't where once that where we combine them in different ways and get partial support for both of them.
I thought instructability was very key in one of your three items that you listed, the last being instructability. And that brings in also the possibility of introducing ethics in it and many other things. So, very many thanks. I have my colleague Todd's hand up, so
Sure.
I will now refer to his question. Please, Todd.
Hi, Amit. How do you like the summers in Colombia?
Not bad actually. There is about 6 weeks period where it is hot and humid, but I've been to places even north that have been much worse with the humidity that they have. So I lived all around the US, and after Southern California, this has been the second best place.
That's interesting. Well, on to the interesting questions. I put two of them in the chat. One had to do with the quality of information that might be used in your knowledge base, or ontology. But the more interesting question came to my mind. You can speculate on this. I don't know how much direct knowledge you have of it. How might quantum computing impact AI, and in particular, its reasoning capabilities?
I was when I got the the Wallace award last year. It was given at the Quantum Week, and so I tried to understand something about the quantum computing, but I must admit that I'm not. And I have a colleague, and he recently gave a lecture in my the institute on quantum computing, but I don't claim to be a very knowledgeable person about quantum computing. It can to the extent that it speeds up processes much more. There is clear value, because you think about it. Today's language models are so hungry of computation, unbelievably hungry on computation. We all know that only 4 or 5 companies can develop these very large language models, and 100 million and up for training. Now, so to the extent that is simply a brute force scaling of computing, great. I think that will be a good value. Is there any other value at a reasoning, knowledge, cognition level? I can't think of per se, other than the fact that to the extent that you go to probabilistic models, I think this will support better. If you think about it, today you can have a very simple entity, relationship knowledge graph. You can have labeled, you can have directed, and other kind of richness. Then you go into probabilistic graph model, for example, right? And in many cases, all you can get from the data is the probabilities. You have to create and observe probabilities. When such models are there, they are very compute intensive, and thereby I think we are not using enough of those. I had one of my students did PhD that involved linear dynamical system, one of the probabilistic graph models, and computation of that, with whatever we had a fairly decent one, but nothing like what huge companies have. It was bad, it was difficult. So I think those kind of things also will improve. But anything at the reasoning level directly, I don't understand that.
Very good.
Well, thank you.
Doug Miles, you have a question? Doug? Okay, if not,
Yeah,
then...
thank you. I had to find my unmute button. So the tool that you're showing here it's actually useful enough that I know people love LLMs. I don't, but had you experimenting with with taking some of these sub things and making them into tools that work on a LLM like ChatGPT. That was kind of like the way Wolfram did with his system.
Do we work with ChatGPT and these kind of systems?
Oh, you know, they made like a tool, a plugin for ChatGPT, and that's, I think, yeah, a little part that said use Wolfram. You know, has this work been something that you feel like would end up making a good plugin that someone could use GPT to inquire of these neural networks?
Yeah, absolutely, absolutely. One of the very interesting application that we are working on is analogy-based pedagogy, and we are working on that with both high school students and, in fact, very specifically, we've been working on the use case of earth science, coursework, using analogy-based pedagogy to teach earth science to high school students. And uh, Analogy has been known to be, cognitive scientists have advocated, a use of analogies for, for education, and that's been widely talked about, but it has not been put in practice a lot because of the scalability problem, because of the cost involved in creating analogies and costs involved in using these analogies in classroom context. Another use case we have is in a large company for employee retraining, because they want to keep the employees retrained with the newer things, and so they can serve the customers better. Now, in this particular case, we can use ChatGPT or basically GPT or other models given a text for a source and target. The source text may be, the use of some historical thing where soldiers were Trojan horse, basically. And the target concept is the principle of cybersecurity, right? And you have text for both of them. Then what we do is to create a graphical representation, because for analogy to work successfully, you have to map one concept from source to the target, and so on. So all the concepts in target should be mappable, should be covered by the source. And secondly, the concept may have hierarchies, there may be an abstract concept that is composed of a whole number of sub-concepts. To create, this graph, from the text, we can use a language model effectively, and that will be a scalable way of doing that.
All right, so you can construct
doing that.
actually all the knowledge that needs to be there in a prompt. In other words, it's almost like you're talking about building up the graph and basically curating for just that moment the information that you would need, and then using the language model on that, using as a prompt. I mean, that's almost like,
Yeah, you do that. There's prompt, an RAG and chain of thoughts, and all those are just being done where humans are taking, you may be using some knowledge to actually create the prompts and or queries, and then you're giving it to ChatGPT. But to have all the right prompts created and the sequence of them created, you are going to, people are using knowledge graph, and they are integrating knowledge graph with LLMs in this way, quite in many cases.
I will have more questions, Amit, but first I want to defer to Ram. He had a question.
Well, my question was simple in terms of how do you test these things?
Which one? I mean, we
like once you develop an application with both neural networks and knowledge graphs, because you got to have two things in here. One, you have to test the neural networks, you have to test the knowledge graphs, and then you have to test the combination of neural networks and knowledge graphs.
No, so here is the thing, right? What happens is that, imagine this, and I'm going to give this a little bit of high level answer with some hand waving. But just basically imagine the following. There is nothing you can do. There is a severe limitation in being testing or validation for the neural network part of it. That's one of the problem. So yeah, you have in neural network there are whole bunch of benchmarks, glue benchmark and super glue benchmark, and you name it, and there are reasoning benchmark, and all of them are there, but they are black boxes. So all you can do is to come up with a graph that shows in so many percentage cases it is right and wrong. And currently we suffer from a huge problem in that those benchmarks are very low level syntactic. They're not very semantic, they're not very application level. So people do publish millions of papers with this benchmark which have a very little real world relevance per se, and or they do not they can show amazing performance with a syntactic benchmark, but in reality where you really need to have context and understanding, they are not as good, right? And we are not yet kept up the pace in creating the right level of benchmark. They are close to the applications and users. So this is a big problem. So the best way to do this here is to really take various issues. Let me give you an example. You take the use case of mild depression, and then work with the experts to come up with all the possible exchanges that you want to allow with the person with mild depression, and ensure that your combined neurosymbolic system, how well it does, and when it is out of bound, create a way to ensure the system does not go there. So as an example, and this is again a high level thing, but I think this will make sense. Let's say that I'm building a mental health chatbot, but I have decided that I should not, I can deal with preclinical depression and mild depression, but I do not want to go to severe depression, and I certainly don't want to go to suicide. Now, if you create the so-called guardrails using statistical approaches in neural networks, it is very easy to jailbreak and very easy to have the system perform and really break, right? And this has happened all the time. So here what you have is, because we have the help of knowledge, I would say conceive of a knowledge graph for mental health, and think about knowledge graph that is covering the area of preclinical and mild depression only, and make sure you saw this you see this kind of picture that I showed you. Now if my text says anything related to suicide, I would know that, and I will just simply not go there. But I know it is suicide, and that's why I'm not going there. If it was simply a neural network system, you are in trouble, because some words may be in some corpus may be very close together, even though from a domain that of the mental health, and as people experts will understand mental health, these things are distinct. In the text and corpus you are trained, they may not be. And so you could end up while talking about some mental health, you could end up talking suicide just because of the bias or other artifacts of how the probabilities were learned from the text. So here our ability to put the guardrail is far better than the statistical guardrail that they can put today using Amazon as something called Neo Toolkit or whatever. You put those guardrails are very, they don't connect with the semantics and concepts in the domain, and thereby they can fail very easily.
Thank you, Amit, for saying that you have limitations within which you want to tune your systems and applications. Finally, we are at the end of the hour, but my last question is, how far are we as a system becoming an aid to mental health experts?
So the way I look at it is that if you want to talk about, if you look at mental health, there are on one hand are use of mental health issues for broad public, like students, like youth in college, like like workers, and particularly, let's say, not children. There we are not too far.
Okay.
And there are already a lot of mental health chatbots available. They do some work, and some of them work reasonably well. As you go more towards clinical part, the simpler medical conditions again will come out in an intimate term, but I don't see currently a timeline for severe medical conditions. It's like when you call the phone, and they say if you have emergency, put down the phone and call 911. So
Yeah.
I think that general strategy is what will be applied, where there will be a range. Some of the simpler, less a range where there is a less safety constraint. There is not vulnerable population, appropriate demographics. We are there, very close to that. But when you go to vulnerable populations and or severe conditions, we are far from thinking about use of AI.
Many, many thanks for covering a very complex topic. I hand it over with very profound thanks to Professor AmitSheth. I hand it over to Ken again. Thank you.
Thanks very much, Amit. And with that, we will adjourn this session, and I will and then ask everyone should come next week, where we will have a panel on healthcare, that will be further considering the same issues that were discussed so ably by Amit today. So thank you very much. Thanks everyone for coming, and
Thanks for
please come
joining.
next week.